Well, good morning. Good morning. Welcome to the webinar as everyone's getting connected and grabbing a cup of coffee and coming in. I'll direct you a few logistics. You'll find a Q&A window, and you'll find and also a chat window that you can use in the Zoom software. And just for a quick sanity check, if you wouldn't mind in the chat indicating that the audio is coming through loud and clear. So if we have to make some adjustments, we can do that. Awesome. Okay, 10:31. Let's go ahead and get started here. And we'll start out with a quick introduction. I like to be personal and pop up here. So I am Jeffrey Palermo, your host for this webinar and the Chief Architect of ClearMeasure Incorporated. We are a DevOps-Centered Software Engineering company specializing in Microsoft and cloud software. And I'm here to present a DevOps roadmap that can help you enable your team to move fast, build your software in a smart manner, and run your system with confidence. And regardless of the challenge that you're facing, you have an important responsibility as a software leader. And my hope is for you is that you'll be able to take away some information that can help your project succeed. So the agenda for today is as follows. We're going to talk about the challenge that a software leader has, and we're going to talk about some symptoms that come along with that, a roadmap for improving and really being world-class at leading your team in whatever software endeavor you're under, drill into some of the details, and then talk about the value that it brings, and then we'll offer some assistance that we can provide at the end. So why don't we dig in? We are not going to take a full hour like some webinars. You guys are busy leaders in the software and technology field. And so I'm going to be straight and to the point and get you out of here. And by the way, at the end, I'm going to be answering questions and sticking around. If anyone has a specific question, I will stick around as long as it takes for your questions to get answered. And I'll also be sharing contact information if a question is more sensitive and shouldn't be done in this public forum. So happy to help. I'm here for you. Okay, so we all want the cycle time to go faster. That's common. None of us ever says, you know what, my software team is moving too fast. We need to slow them down. But as we move faster, we also want to make sure that we preserve quality. So we want high speed and high quality software delivery. And we want to move to a cycle time that's controlled by us, days, hours, possibly minutes, as opposed to months, weeks, quarters, things like that. And of course, we're oftentimes put in a situation where we're asked how long it's going to take, and we have to give them an answer. And it's not a good feeling when we don't know or we can't count on an answer that we ourselves are giving. So that is the universal challenge before us. You know, some of the symptoms that we're encountering are just that. They're symptoms. They're not actual root causes. And probably every one of you has encountered a disruptive or a long error-prone deployment or longer lead times than you would like, or maybe you just know in your gut you can sense a risk that isn't really being mitigated. You know that it's there, but you can't quantify it and you can't figure out how to identify and then mitigate it. But really the root causes of some of these can be more the bottom right, an insufficient work environment. And I'm going to dig into that a lot in this webinar today, and that we are running software teams, whether we have an existing Microsoft platform, custom software system that's been around for a long time, and we need to modernize it. And our people are telling us we have to rewrite it, but that's a non-starter. There's no way that we're going to reinvest millions of dollars with the size of the system. We have to figure out a path forward, or whether we're building a new piece of software or a meaningful expansion or moving to the cloud, we have a big project in front of us, and our team needs a sufficient work environment. And if something in that work environment is missing, then they don't have clarity on how to proceed. It could be something missing in our software process, or a root cause could be lack of visibility, lack of transparency, or lack of a metric, a method in order to know where we stand. So I'm going to talk about the roadmap for DevOps, and this is holistic. I've been a professional programmer in this field for over 21 years now, and I was an early adopter on the Agile manifesto when it came out, and continuous integration and all the practices, test-driven development, extreme programming that have come through. I've been certified Scrum, this and that. And so I've gone down the whole path, and DevOps piggybacks on a lot of those things and carries it forward. So we're really in a progression as opposed to a replacement. But this is the conventional view of how a software process goes. It's a cycle. We plan, we code, we integrate, we package, release, we operate, we learn, and then it goes back into planning. And a lot of times when we think about DevOps, we think about, we need to have an automated DevOps pipeline. We need to have an automated build, and we need to have an automated deployment. That is absolutely true. You do need that, but that is just the foundation. That is just how you get started. It's not the definition. It's not the finish line, because the ability for your team to have a very quick cycle time around these activities, that's the goal, so that you can be nimble, you can change, you can deliver, you can deploy your software whenever you want to deploy the software and not be beholden to a particular cycle. And the automated DevOps pipeline is the center, it is the hub around which we do this, but it is not the complete process. And I'm going to fill this in so that you have a complete roadmap of how to get there from a leadership perspective. Okay. So before we move on, let's just touch on a concrete implementation of the pieces of that DevOps pipeline. And this is an example and I know it still says the Visual Studio Team Services instead of Azure DevOps Services, but this is an example of a very popular implementation where you have Azure DevOps Services or Azure pipelines integrated with Octopus Deploy and pushing to Microsoft Azure or AWS. And you have certain capabilities like in the bullet point on the bottom left. And you have your private build, you have your continuous integration build, you package up the components of your application, you put it in Azure Artifacts so that you have appropriate package management. And then you have a minimum of 3 environments in your pipeline. These are environment types. You'll never have fewer than 3. You have production, then you have manual test, and then you have automated test, which is the first line. And those builds off of feature branches can go there. You can have 7 environments, but these are the 3 distinct types. You can have multiple manual test environments depicted in the middle. And by the way, I know that this text is small. If any of you would like our full DevOps pipeline architecture in poster format, just reach out after the fact, and we'd be happy to get that to you. This is part of it. And so these are the critical elements of that pipeline that I just wanted to show you briefly. But I want to talk about the things around the pipeline once you do have this in place, because you're not done when you're able to just automate your builds and automate your deployments. So there is more to it, and these are the layers, 5 additional layers in this process. And I want to talk about the challenge in our industry as it related to and similar to, let's say, an auto mechanic shop. So consider this story. A gentleman wanted to start a mechanic shop, had the vision for to compete in that industry, finds a location, builds a brand new building, beautiful building, and then goes to the local auto mechanic school and talks to the dean of the school and says, all right, you have a graduating class coming up soon. I want your top graduates. I want the top 7% of your graduating class. I can pay what it takes to hire those folks that are coming out, and only the best will do. Goes to buy some equipment and has some pallets of Snap-on tools delivered, beautiful new tools and equipments for the shop. Then graduation day comes. He, in fact, does hire the top 7%, the smartest, most accomplished graduates of that auto mechanic school. and they're out in front of the building and they're having a meeting, and the owner says, "Okay, team, this is going to be exciting. The customers are going to come. We have a short time to get ready. Let's get ready." And then walks away, and all of those graduates, new mechanics, top from their school, the top 7%, they look at each other wide-eyed, and some terror goes through their minds because they were never trained in how to set up their own work environment. They were trained in an environment that was set up for them. And so we have a lot of that in our industry. And you probably have learned over the years what some of the important things are in order to set up your environment, which includes how you work, the tools, the processes, how all the different things fit together and why they're important and why you do certain things. And you probably learned from making mistakes or just going through a number of projects over the years, but just recognize that that has not been a formal part of education for most of the people in the industry. And so we as leaders, it is our job to properly equip our team, soup to nuts, with the ability to be world-class. And that's what we're talking about. This roadmap to what I'm calling DevOps-Centered Software Engineering that fulfills the vision of DevOps, of moving fast, doing everything in a smart manner, and then running the system with confidence. And so I'm going to talk about these missing 5 layers in this overall DevOps process. So of these layers, each must have a sound strategy, be executed with discipline, and have objective measures. And does that sound familiar? It's kind of like everything else in business. It's not enough to say that you have equipped your team with, for example, defect removal. And your strategy in this case would be the selection of defect detection methods. And here we benefit from the software research of Capers-Jones, who spells out the combination of defect detection methods that are proven to achieve the needed quality. And so in this example, our sound strategy would take the guesswork out of the process for our team, because we would equip them and say, "Hey, let's use these methods. We're gonna implement them as such, and then have a rhythm of executing and checking on that, and then measuring how it's going." So let's quickly touch on the layers that make up a complete work environment. So the first layer around our automated DevOps pipeline and having that infrastructure in place is best practices. And one example best practice commonly selected is the use of stable, reusable components. And I just have a whole list of practices on the left-hand side that tend to be useful in a lot of different cases. Most people don't implement 100% of them, and there's lots of other practices that are really good. But it's up to you to pick which practices are appropriate for your situation. So let's talk about stable, reusable components as an example. This practice is also backed by industry research and drastically cuts down on custom development costs. And in the .NET world, these are often NuGet packages. Even among teams that have declared that they like to buy versus build, that they reuse, we often find when we come in and do an assessment, we often find large sections of code that could have easily been replaced by one of these packages, whether open source or commercial. And we find that team managers, the software leaders, are often unaware of the missed opportunity to save significant chunks of schedule, and are unaware of the existence of a lot of that custom code, and of possible other risks that putting in place that custom code poses. And so that's one of the examples. But ideally, the ideal state is that you choose your practices strategically. You really think about it and have a reason for choosing the practices, apply them, and add controls in place to make sure that they're being done. And there's so many practices out there. It's important to actually choose and lead the team and specify the practices that you're using, as opposed to expecting all of your team members to be self-led and just organically choosing the practices. It's our job to align our team, and this is one of those aspects. The next layer is defect removal. I want to dive into that more than just what I touched on. But it's not enough to validate the code only after the fact. We can find problems at that point, but we're not very good at preventing them. And we're not going to find all of them by just manually testing the code or even automatically testing the code. It's interesting that research shows that far less than half of the defects of the software as a whole are actually in the code. So here's the distribution on average. For every 5 defects, 1 of them comes from bad requirements or analysis gaps, things like that. 1.23 comes from bad design decisions, even before code was written. 1.75 of the 5 come from the code. 0.6 are problems or errors in documents around the software. And then 0.4, which is almost 10%, come from bad fixes or trying to fix a problem and then essentially creating a new one. So that's the distribution for every 5 defects. So go all the way back to requirements, 1 out of 5, that's 20%. 20% of defects in the software come from a problem figuring out what to do, which is requirements, figuring out what the heck to do. So code represents 1.75. So it's not enough just to check the code after the fact. There's an interesting white paper that I would encourage you to read. It's called Software Defect Origins and Removal Methods. The author is Capers Jones, published in 2012. You can Google for it. And the title again is Software Defect Origins and Removal Methods. And based on the type of software that we have, we need to strategically select the defect detection methods and defect removal methods that are shown in the industry to get us above 85% defect removal. That is only allowing 15% of total defects to actually make it into production. Now, if we're shipping software that's going to be embedded in other software, we need to be at 95%. And these are levels that are backed up by research from the Software Productivity Research Group. So it's really important that we think through this in a sober fashion, because if we're doing, let's say, just a dynamic website that's a portal that connects to another system, that's very different from if we're doing system software or software that interfaces through a PLC with, say, industrial equipment. Just the nature of the software is different. So you have to choose different defect removal methods and embed it in your process, embed it everywhere. Not just think that we're going to have something done after the code, but have a quality control check at every stage in the process, including quality control to make sure that requirements are not wrong or missing something and then moving downstream. So one of the major defect origins, and if you go in that article, you can see some of the research here, happens to be unapproved reused code from external sources. It's in the short list of major defect origins. Now, just in the previous, I touted the benefit of using proven, stable, reusable components because they're defect free. Lots of people are using them. The defects have been worked out, and yet, if a package comes in from an outside source without your knowledge and it's not approved, that scenario actually in the research accounts for I think it was a top number of major defect origins. So NuGet is great for packages strategically identified, but take a look or maybe interview some of your team members. What we find is that many teams, the developers are developing something and they find external packages and they just pull them in. And there's no vetting process and there's no visibility to that. And it's not done. It's not done at a formal level or a visible level. It's done, and then you catch it after the fact, and all the code has already been done, and it's deeply integrated. And so it's important that you vet the author and the origin of those packages, because whether it's NPM or NuGet, anybody can publish it up there, and it's not like the App Store. There's no oversight. Anybody can publish anything I mean, you could publish a overt virus and it's going to be there for a while before it's found out. But it's important to know specifically what dependencies are being pulled in, so that they're from reputable sources. And there are lots and lots of great reputable open source packages as well as commercial, but just know what they are. All right, so that's defect removal. The next is team workflow. And one of the rampant problems, unfortunately, that's, I think, in our industry, but it's probably not unique to our industry, is that teams and actually individuals have multiple backlogs. They have to check different places in order to receive their work. Even if there is a project tracking system where they work through tickets or work, a lot of times work comes in from other sources in their email inbox. To take this experiment, let's say you have a person who is 100% dedicated to a particular project. Chances are, if they did not check their email for a couple of days, they would miss a new assignment coming in through that channel. And so if you kind of look at that example, that shows that we have at least one additional work stream, multiple pipelines of work, and so it's hard to keep track. Now, within our project tracking tool, Azure Boards or TFS, or some people use Jira, we want to have clear statuses. It's not enough to have not started, in progress, done. Because remember, just the 5 categories of defects: requirements, design, coding, documentation, and bad fixes. Those are defect origins. So we need to break down the process for creating and analyzing requirements, for making design decisions and specifying design, and then the stages of writing the code, inspecting the code, vetting it, testing, and then, of course, user acceptance testing, deployment, release configuration. There's, in your organization, if you just map out the workflow, you have plenty of stages. It's common for us to see, between 8 and 10 statuses, therefore 8 and 10 swim lanes on a properly configured board, as opposed to 3 or 4. So if you don't use that granularity, you're missing out on visibility. And any change between those 8 and 10 swim lanes when a card moves over, that's motion. And if the motion in the team doesn't reflect in the work tracking tool, then you'll have a bottleneck that will happen. It'll remain hidden, and then it'll sap the schedule. And your complete workflow sheds light on every bottleneck source and enables the team to have a constant, predictable flow that can be tuned and measured. Okay, so that's team workflow, and that's making sure that you have every bit of activity that needs to get done tracked. And by the way, once you do have that, all of these tools, especially Azure Boards and Jira, actually have really good APIs where you can pull the data into an offline data source and do some really interesting business intelligence queries to gain insight into throughput and lead time and cycle time, even beyond the built-in metrics, which are actually quite basic. So it's really important that you have your complete team's workflow modeled out so that anything that anyone does is visible. And that's actually, if you read the yellow DevOps book, which is the sequel to the Phoenix Project, it goes into more detail in one of the first principles of the first way of DevOps, which the first way of DevOps is flow. And therefore, a lot of us think of the automated DevOps pipeline as, oh, that's flow. As long as we're building and deploying, we've accomplished flow. Well, not exactly. We're not done yet. One of the first principles within that is make work visible. Make all work visible. And so that includes anything that anyone has to do is work. And we need to make sure that that is visible in our project tracking tool. So Azure Boards, for example, you can configure any work item type under the sun. And oftentimes we track risks or a project management task or a meeting or a sprint planning, sprint review, retrospective, all kinds of things that need to get done. If it needs to get done and somebody needs to do it, then it needs to be a work item type and it needs to be tracked as such. Otherwise, we're tracking, if we're only tracking features and user stories, then we're going to be leaving out some work and we're not going to have the full workflow. So this is a critical area in really making our team world-class, because we need to take the hidden bottlenecks that is sapping their schedule and squeeze out that waste. Okay, the next layer is architectural blueprints. And the best model that I believe exists out there in the industry, and maybe there's some variants, but it's called the 4+1 view model of software architecture. A gentleman named Philippe Christian from Rational Software, way back in 1995, put out a white paper called the 4+1 view model of software architecture. Google for that, and you'll find it pretty easily. And there's also a YouTube video of an interview talking about that. But that was back in 1995, a full 6 years before the Manifesto for Agile Software Development. And to this day, I believe it's the best method for emergent iterative architecture. And it describes it describes the different layers for us to visualize what is being built. Okay. So strategically, you are defining what is being built, what is cleared for investment, what is prioritized to be implemented, as opposed to what's not. What's not. We're going to intentionally defer some things. Every profession that builds something uses design drawings of some sort and design models in the communication of what is to be built. Teams, if your team lacks this, then they're constantly struggling to put the same image in the minds of each team member. If there's not an image that we can all look at, then you as the leader, you have an image in your head about what the shape of the system should be at each particular milestone, each particular release. And the shape of the system could be, different along the way, because a key dependency may come in, in release number 2 or 3 or alpha, beta, or whatever you call it. And so we have an image in our mind, and we can talk and we can whiteboard this and that. But unless we have a complete set of drawings of the different dimensions of the software, then our team members are going to hear what we say and take all their information, and they're constructing their own image of the system in their head. And it's going to be different. So it's important in whatever form or fashion that you have architectural blueprints for your system. I don't think any of us would dream of building a house, or sometimes even a storage shed, without some type of drawing of what it's going to come out looking like. It's the same thing with software, and software is so much more complex. So I implore you to go back to your team and look at the state of your architectural blueprints and ask yourself, okay, are these up to date? If we were briefing someone on the structure of the system, is that what we have? So we often ask about how the system is structured when we go in and do an assessment with our clients. And far too many times we spend, let's say, over an hour in a conference room harvesting the architecture out of the heads of the team members that have been working on the software for a long time. And then we draw it on the whiteboard. And so this is a tool for team alignment. And think of it as a software leader. You have a business plan so that the executives in the company can be aligned. You have a marketing and sales plan so that department in the company can be aligned. Same thing. The architecture is the plan for how the software is going to be constructed. Imagine a business with no business plan, or market strategy or quarterly goals. There's no alignment. Same thing here. And so the 4+1 view model of software architecture, it espouses the 4 layers. The physical layer, how is it going to run in production? Cloud, on-premise, how many servers? 1, 16, how are they structured? That's physical. How is it going to run? Logical is how all the dependencies and the different parts of the system depend on each other and relate to each other. The process view is that for a common transaction, what is the flow of data and the change of control in the system as that transaction is processed. So when connecting the arrows in the system, the logical layer has arrows in the direction of dependency. In the process layer, the arrows are in the direction of data flow. And then the fourth layer is the development environment. And this is left out far too often. And you can kind of, a symptom of it is when a new person joins the team, a new developer joins the team, they're kind of being told off the top of their head, oh yeah, you got to install this and you got to install this and you have to set this up this way. And yeah, it's going to take a couple days to get the system working on your box. And then one of the team members says, oh yeah, and you also have to install this tool and configure it this way, because there is a shape to the development environment. There are things that have to be put together a certain way in order to change the system, change the source code of the system. And so the development environment, which by the way, the automated DevOps pipeline is a critical part of the development environment for your particular system. And then the plus one is the capabilities of the system at that point in time, which makes it iterative, which makes it emergent, so that you can specify the architectural blueprints at initial minimum viable product stage. Say, hey, at this stage, this is what the system's going to look like. And here's the scenarios, just a bullet list. Here's the scenarios of what functions it's going to support. Then at our next release, our next major release that we're thinking up in our head, the system is going to be shaped differently. And there's going to be some more architectural concepts. Why? Because the list of scenarios is longer. And I'm not talking about user stories here. I'm talking about big capabilities that would impact the architecture, so that you can essentially draft the architecture in Visio, store it in the Git repository right there with the source code. And so you can go back in time and you can see the different versions. All right, so architectural blueprints, really important. The next layer, the outer layer, is operating the system. And I label it cloud operations because that's the way of the future. And even if we're going to run our own data center, we're implementing a lot of cloud practices, even in our own data center. Infrastructure as code, spinning up new environments on the fly, hybrid structures where some stuff is in the cloud, some stuff is on-premise. But operating the software system is how we make sure that the people relying on the software are receiving the full value of it. Developing is just getting started. People use it, and that's when we can get our organizations can get a return on investment. If we rely, for example, on a user to report an issue with the software, then we're only capturing a subset of the information that's available. We should see that a user is struggling, much less receiving an error when they're using the system. We should know what's happening with the system. We need to design and build the system so that it is observable. I remember back in 2005, the industry had a big discussion about test-driven development, and one of the elements or character traits of a piece of software was testability. Well, in today's DevOps world, the character trait of observability is being talked about a lot, and it's critical in order to know what your software is doing. Many teams have some logs, for example, or some telemetry or some performance counters, but they don't have enough. They don't have enough information. And when something goes wrong, someone with administrative access to production has to remote into a production server to look through the logs and start piecing together what is happening or what happened. There's no aggregation. There's no performance timings. The goal is to make the systems completely observable from an external perspective without requiring production server administrative access. And so we want to centralize the logs. However that implementation works in your scenario, we want all of the logs and telemetry to be centralized in one place so that we can query it using business intelligence methods. And once we structure and pull all of that data together, it's just another data source, much like the data source that the system is a steward over. And because it's a data source, we can use any number of business intelligence and analytics tools in order to gain insight from it as a data source. So in cloud operations, we need to change our thinking about logs and telemetry and performance counters and all the information that our system can give off. And we need to think of that as a data stream, and then put together a little miniature data warehouse of the logs of our system. And then we can query it and gain insight into what it's doing. And when we do that, we will always be a step ahead of our users, because when something starts to look abnormal, our staff can immediately jump in, be equipped with the tools and the visibility and the data to know what's happening. And oftentimes they can prevent a business disruption because they jumped in and say, oh, this is happening. Let me go ahead and fix it. And they'll know who's trying to do what, especially if it's an internal user. I mean, think of the experience. You call, hey, I saw that you were having a problem. By the way, I went ahead and fixed it. Go ahead and try it again. And it'll work now. Apologize for the disruption. I mean, talk about loving your group, as opposed to an experience where maybe some of your users say, yeah, software doesn't always work. And when I put in a ticket, nothing happens for the rest of the day. So what's the use of putting in a ticket? So it's a completely different experience. And you're going to be the hero, because your team is going to be world-class and you're going to be a model for the rest of the organization. So we've kind of gone through these layers, and the process around the outside: plan, code, integrate, package, release, operate, learn, is enabled with, you have your automated DevOps pipeline at the center. It's the foundation, it's the core. And then you have these layers, and on the items on the top left are strategic. That is your strategy. Everything in business requires a strategy. You have to determine what approach you're going to take. And so you need to select your practices that are appropriate for this particular situation. You need to select how you're going to handle the constant threat of defects. You need to select what and visualize your entire team workflow. You need to define your architecture, and you need to centralize your logging and structure and design your logging and your operation strategy. And then you need to execute. You need to equip your team to constantly execute, make sure that they're actually using the practices that have been agreed on. Make sure that they are faithfully executing the defect detection and removal controls. Make sure that they're executing the workflow put in place, updating the architecture, or make sure that they're implementing the architecture that's specified, and that they're monitoring the alerts in production. And with all of these layers, then you can measure what's going on, because you've actually put in place the strategy and you've set your team onto executing. And then you can measure, and you can put together your dashboard, and you can have reports from your software. So implementing this in a few examples, I have some examples on the screen, and I won't spend a lot of time on this, but there are huge results, huge value that is derived from putting all of these layers properly in place, putting in place a complete DevOps environment, and then equipping the team to execute a insanely short cycle time. It's transformative from having scheduled out releases to being able to release and deploy your software at any time, because it's always stable. It truly is transformative. And I put some examples on the screen for you there. I'd be happy to share more information about you later. But we hear of teams who move fast at Google and Netflix and Microsoft, but any of your teams can be just as effective when equipped properly. That's the magic. And that's my hope for you, is that you can take some information today and improve your team. So there's a few ways that we engage with clients to help them down this path. And one is to help your team be completely self-sufficient in your software project. And you have a team that's run by you, and we come in there and analyze all of these different layers that we talked about, make some recommendations, help you fill in the gaps, help you define the strategy, the method of execution, the method of measurement, and then provide some coaching so that you can execute your project in this manner with a fully equipped DevOps environment. The other method is the guided method, where you want us to just stay alongside in a in a more intensive care aspect and do it with you. And from project definition to just providing a DevOps assessment, we can review your software, review your practices. If you need to modernize a system, we can look at your modernization roadmap and help you out with a modernization plan as well, and help you execute whatever project you have in front of you. But if there is a big challenge or a big project that you have going, we would love to talk to you about it. And if you need us to take care of anything under the sun with Microsoft or cloud, Azure, .NET, Visual Studio based software, that's our specialty. We're a Microsoft Gold Cloud and DevOps partner. And here is my contact information. I'm going to go to the questions that were posed and go into the questions, but I want all of you to have my contact information. And after this, feel free to call me on the phone. We can chat. We can talk about whatever's on your mind. You can email me. You can find me on Twitter. I'm pretty easy to find if you Google my name, and there's plenty of other videos that are out there. And so let me go to the questions here. Am I able to get the diagrams that you showed in the slide deck? Absolutely. So thanks for that. Thanks for that question. We'll follow up with you on that, and that's no problem. Another question that we have is, do we have to implement all of every layer in order to implement this complete DevOps model? The answer is no. Everything's incremental. And so you think about it, if you're getting started on something, you need, and let's start from the core. Let's say you don't even have an automated DevOps pipeline. You need the basics. You do need, one Visual Studio solution for one Git repository. You need one continuous integration build for that one Git repository. Then you need a series of environments. You need to build it once and deploy it multiple times. Keep the configuration out of the source control. And then that's just your basics. And then you need the practices. And by the way, I didn't talk about static code analysis or multi-level test automation, because if you're just getting started, you need to do just a thin slice of everything and then move on. So then practices, choose a few practices that are obvious and say, okay, we're adopting these. Let's get going. Defect removal. Pick a few control points for defect prevention and defect detection, and then move on. Map out your workflow with maybe a 1-hour session with the team of, hey, what are the stages that we're going to move through? And then configure Azure boards with all the swim lanes. Then move on to Azure architecture blueprints. Have a whiteboard session. Let's say, hey, for right now, how are we running this in production? Physical layer. How are the logical modules slated? And put that together, and then move on to cloud operations. Say, for the functionality that we have, how can we centralize the logging? Then get that in place, and then you iterate, and then come back and say, okay, let me go back to my DevOps pipeline. Now, do I want to add static code analysis, Independ, SonarQube, Visual Studio code analysis? Do we want to add JavaScript linting or resharper command line code analysis? And then you can iterate all the way back. So your team, as they're developing in iterations and developing features, you as a software leader can be iterating on the sophistication of your entire environment and your entire team's process. So that's a really good question. Nothing is big bang. Everything is incremental. Okay. All right. I think some of the other questions were answered on the back channel. Okay, so this has been fun for me. I love sharing this information. Thank you so much for being here with me today. I'll leave this contact information up on the screen. Feel free to do a screen grab, and we'll close down the webinar at this time. But I'm available if you want to just give me a call and ask me a question. Feel free to ring my phone, and I'll turn the ringer back on. And it was great being with y'all. And have a great day. And we'll see you next time.